2012 AMC. This is problem 23 from the AMC12A, and it's a fun little probability problem. It says let S be the square, one of whose diagonals has endpoints 0.1, 0.7, and negative 0.1, negative 0.7. A point V equal to xy is chosen uniformly at random over all pairs of real numbers x and y, such that x is between 0 and 2012, y is between 0 and 2012. Let T of V be the translated copy of S centered at V. What is the probability that the square region determined by T of V contains exactly 2 points with integer coordinates in its interior? Okay, that's a mouthful right there. So let's do some sketching, see what we can see. So here is a quick diagram of S, not the translated S, but 0.1, 0.7. And negative 0.1, negative 0.7. Okay, and since this is a square, I can determine the other two coordinates. I'm not going to... I'll write them, whatever. Okay, so this is going to be 0.7, negative 0.1. And this is going to be negative 0.7, 0.1. Okay, so here is our square. And what a lovely square it is. And here's the trick to the problem. I can translate it anywhere, but basically, probabilistically wise, the 2012s make no difference other than the fact that they are all divisible by 1. So it can go anywhere within reason. And here's the thing. If I want two points in there, I can either have this one case where one of the points falls in this area and the other one falls in this area, where the distance between the points horizontally is 1, and I'll explain more why it has to look like that shortly. Or I can have the case where one of the points falls in this region and the other one in this region. Okay, so okay, we know that integer points are 1 unit apart, and I'm not going to spend too long showing it, but I can't get more than 2 points in here. But here is the big idea. Right here, this is going to be of length 1. And so anywhere, if I'm right here, if I go 1 unit to the right, you can see I'm still within my blue square. So if I hit an integer in this area, an integer coordinate, then I'll get another one in this area. And similar argument for this with the vertical distance being 1. Next thing to notice, the delta x and the delta y, for my little distance formula, Pythagorean theorem, whatever, delta x is 0.8, delta y is 0.6, and so I know that this is a 1 by 1 by 1, well, 1 by 1 square. And I also know that the ratio is going to be 6 to 8 because of similar triangles here, the way it works out. And so, because of the way this all works out, because of the slopes causing similar triangles, this has to be of length. So if this is 1, I need to have a length of 0.6 and a length here of 0.8. Okay, and if you need to see more of it, you can rotate things, see that this triangle actually fills in this triangle over here. Because of that, my yellow rectangle over here, well, this whole length was 1, so that means this length right here is 0.4. And this whole length was 1, but right here was 0.8, so this length right here is 0.2. And the area, we're going to go after the areas to find the probability of this, is 0.4 times 0.2 equal to 0.8. And the same argument can be made with the 0.6, 0.8, giving me 0.4 and 0.2, saying the area of this one is 0.8. And same for these two. But I don't need those two because if one of the points falls in here, well, one of the points fell in here. I've already accounted for that with my 0.8. If one of the points falls down here, one of the points already fell up here. I already account for that with that 0.8. So the probability that I get an integer in here is 0.8 over the total area. The total area of a 1 by 1 square is 1. The probability I get an integer point in here is 0.8 over that total area, still 1, which gives me 0.16, and my answer is C.